When we communicate, how to measure whether two addresses are in the same network segment. First step. During communication, PC1 is now called the sender. It is sending data externally. The host on the sending end will use its own mask. Add the IP address of the other party for calculation. The result of the operation is the network segment of the peer end. The network address. After calculation, compare the peer network segment with your own network segment. If consistent, then the message will be sent. That is, if they are consistent, they are considered to be on the same network segment. For PC1, if we do the calculation now, what is its address? Let's calculate. 192.168.1.000000001. The mask is 25 bits. Then the mask is 255.255.255.100000000. So am I trying to come up with what I have now? So now to get the network address. The mask is now only these bits, corresponding to the IP network segment, is also the network number. This is the content of the subnet mask mentioned earlier. A subnet mask of 1 corresponds to the network bit. A subnet mask of 0 corresponds to the host bit. Let's not talk about the first 24 bits being 1. It is 192.168.1. Then the latter bit corresponds to 1. This one is sure. That is actually 0. I don't even look at the corresponding ones behind, because the mask is now all host bits. So actually, the network segment I counted is this. The network segment is a 25-bit mask, because the mask of PC1 itself is 25 bits. So this is what PC1 thinks is its own network segment. Next, PC1 will calculate the network segment of the other party. The network segment of the other party is 192.128.1.2. Then 1.2 here is 10. This is called the peer IP address. Then take your own mask to calculate. You will find, when the calculation is over, now own mask is still 1. This bit corresponds to 0. All previous values. That's how it works. The last 7 bits are all 0. Calculated is also 192.168.1.025. This is the network segment of the other party calculated by PC1. Now PC1 thinks they are in the same network segment. Then the data is sent. The data has arrived at the peer. This ping pays attention to back and forth. Send a packet. Send back a packet. That is, now I want to actually do network communication. Just sending this data packet will not work. Still have to send it back. So before sending it back, PC2 also needs to perform calculations. Calculate whether they are in the same network segment. It is 192.168.1.2. 1.2 is 000000010. This is what PC2 thinks is its own IP address. Its own mask is 255.255.255.110000000. Then the next step is to calculate its own network segment. In fact, these two corresponding network segments, these 2 bits correspond to the determined value, is 0. So the network segment is 192.168.1.0. 26-bit mask. PC2 should now take the other party's IP, calculated with myself. The other party's IP is 192.168.1.000000001. PC2 thinks that the network segment of the other party is 192.168.1.0. 26-bit mask. Now PC2 receives the data packet sent. See that the address of PC1 is 1.1. It takes its own mask and calculates PC1. Found that they are on the same network segment. PC2 communicates with PC1. In the process, while host A and host B for us, we know they are not on the same network segment. But the device itself does not know what the mask of the other party is. So when they communicate data, what you see is your own mask plus the other party's IP. Calculate the network segment of the other party. So the PC thinks that other PCs are on the same network segment as it. It sends packets to other PCs, or reply packets. It thinks that it is not on the same network segment, and does not send data packets. Let's do a harder one next. We replace the right side with 192.168.1.5. 30-bit mask. First of all, let's change this to 192.168.1.5. Let's calculate together now. First PC1 and PC2 go to ping. Definitely take your own IP. Own mask. Own network segment. This is no problem. Its own network segment is this. Now take the other party's IP and add your own mask. The other party's IP is 0.5. So it's 0101. Now it thinks that the network segment of the other party is still this. So in fact this packet can be sent out. No problem. Now the packet is sent to PC2. For PC2, its IP, mask, and network segment, there is no problem. Now we have to calculate the following part. Now it is the IP of the other party. Add your own mask. Own mask is 255.255.255.11111100. I feel like I can't get through. Because you may feel that the mask I wrote is too long. IP is 192.168.1.000000101. Now it's time to start calculating. Calculate your network segment. 192.168.1.4. 30-bit mask. So now we have to calculate with the other party. The other party's IP is 192.168.1.000000001. Then the network segment of the other party is 192.1681.0. 30-bit mask. When the calculation is over, found a problem. PC2 is now 1.4 network segment. PC1 is the 1.0 network segment. They are not in the same network segment. So it stands to reason. PC2 has no way to reply data packets to PC1 now. Let's come to PC1 here. Go to ping the address 1.5 again. Unreasonable. There is a timeout here. Mean timeout. So no ping. That is, the packet was indeed sent. PC1 sends a packet to PC2. Because PC1 thinks that the two are on the same network segment. But PC2 did not reply the packet to PC1. Because PC2 thinks that the two are not in the same network segment. Then everyone will find out. No matter which mask. It does not seem to belong to the three categories of ABC we talked about before. We call a class like ABC the main class. This is defined by the organization IANA. Then these are